complex numbers to polar form. I just looked up who actually invented the complex numbers to polar form, but I thought maybe it would be someone from Antarctica, but turns out it was Isaac Newton, so no polar bears or ice involved in this one. Alrighty, probably just wondering what polar form is. And as I said, it's got nothing to do with polar bears. Polar form. You got your normal complex number. Let's go to Z. So you got A plus BI. That's your normal complex number. The polar form would be converting this what would be considered as rectangular components into something r cis theta. Can write that a lot neater. Converting it to r cis theta. Probably cis, not a step cis, not a cyst, but r cis, which is actually it's further equal to r cos theta plus I times sine theta, where r is our radius, which I'll get to in a second, cos is cos, I is I, psi is sine, and theta. That's where in the polar form theta gets interesting. Our value of theta has to be in between these values here. Less theta has to be greater than, I don't even know what I'm saying at this point. Negative pi has to be less than theta. Yep. And theta has to be less than or equal to pi. So pretty much in your unit circle, it falls from here, goes all the way around to here. That's pretty much where it is. So you have to make sure when using polar form that the argument, so argz, falls within this range here. Otherwise, your whole polar form, the whole thing, it's just destroyed. Right, now we'll get into how to actually convert the rectangular components of a complex number into polar form, which is pretty straightforward. I remember I hadn't touched on it for ages, and I would just look at one question, and I got it instantly just from almost common knowledge. Yeah, so you should be able to do this without watching the video if you don't know how to do it. Alrighty, let's just get started. I'll just use one of the examples that I got here because I actually went to film this one just a couple of minutes ago, and I wanted to write an actual example that had like a legitimate answer. So I had to quickly go find a couple of questions to do. Kind of expand this one, make it larger. It's not going too well for me. There we go. That's a question there. Actually, there's no point in. I just need to get back up here. That was a waste of time. Alrighty. So our first part, we'll have z is equal to -1 minus r. First part to getting the question right is writing the right question down. It always helps. -1 minus I. Now, the first thing when you want to convert it to r cis is find the radius. And r is equal to the modulus of z. I usually don't like the term modulus of z because I always think the modulus function, I always think it's meant to look like some graph. So I just go magnitude of z. In other words, in another video, we had this here. We had our imaginary and our real axis. Now on this, we clearly -1 this way and -1 down here. So therefore, we want to find, we're actually trying to find our distance from -1. We're trying to find our radius or distance as such at that point. So r, which is equal to the square root, so it's just pretty much using a distance formula. Square root, -1 squared, and then plus your other value here, -1 squared. So you've got our real part, our imaginary part. Real part, imaginary part. So pretty much you just square root and then just go your first, so square root, grab your first value, square it, plus, grab your second value here, which is -1, and square it. And that's pretty much it. And that's how you find r. So you can simplify it to, it'll just be 1 plus 1, which is equal to 2. So our r is equal to square root 2. And once we've found our first value, we know what r is. Now our next step is finding theta. And this is a bit more challenging. You can sometimes come across shortcuts to find it more quickly, but I'm just going to do the longer way to guarantee safety when doing this polar coordinate type stuff. Alrighty, so I've got our r is equal to 2, square root 2. That's it. And next you want to find cos theta, sin theta. So we know from our just polar coordinate itself here, we know cos theta is going to be equal to our real value, which is -1, over our radius. So pretty much the normal trigonometry thing, because it'll be adjacent over hypotenuse. So you'll get -1 over the square root 2, and then sine theta is equal to the same thing, -1 over square root 2. And then you can evaluate from here, but if we go cos theta is equal to -1 over square root 2, it can actually be one of two values. It can be here, because we know the cos is negative here, or it can be here. That's no good to us. We actually want to know its exact position. We can do that by looking at the sine value, where the sine value is also negative, so sine here, or in the third quadrant as well. So we know our polar coordinate, and we also sketch it down here, but we know it's in the third quadrant. So you could very much just chuck a sine inverse here or a cos inverse here and call it a day. But I like to guarantee and find a tan theta. I just find it to be usually a bit better. So you just got -1 over square root 2 divided by -1 over square root 2, which is equal to 1. Now, actually, this is where the other values help you out in finding this. So we just chuck a tan inverse 1 here, and therefore we find theta can be equal to a couple of things, but we know that tan inverse 1 will be equal to 1 when it's in the first quadrant and the third quadrant, and we know our values in the third quadrant. So therefore, it could be equal to a couple of things here. That's what, actually, we're going to write that down. It could actually be equal to 5 pi over 4, or it could actually be equal to -3 pi on 4. But what do we know about theta? We've got it right here. It needs to be between these values, and we see 5 pi on 4 is outside this range here, whereas -3 pi on 4 is inside that range. So therefore we know that -3 pi on 4 is going to be our value. So once we've found theta, that's pretty much just game over. We know our r cis. So r cis, actually we'll just write the full thing out here. We got r cis theta. So we got -1 minus I is just equal to square root 2 cis -3 pi on 4. And I haven't checked the answer, but from this process and me just being confident with my math ability, I'd assure you that that's the answer there. I'll just do another one. Not sure how long this is going to go on for, but I'll just do another one just in case we get any wacky values. But this was actually a good one because I walked you through the problem solving of when theta actually falls outside the value, falls outside the what's it called, the domain that we want for theta, but also when tan theta equal 1, you can get multiple values. Like it could have been pi and 4, it could have been like 5 pi and 4, as I said. It's really interesting. Yeah, you could have had another value here, 5 or 4, because that's technically right, but we know that it's in quadrant 3 from our cos and sine values, so therefore that's how we knew what its actual value was. Alright, I'll do another quick one. I'm going to do 1/2 minus 3 over square root 3 over 2. Alright, so I'll do that down here. Not sure why it doesn't let me go all the way down. Alright, I believe it was 1/2. I'll write this further down. 1/2 minus square root 3 over 2 pi. I believe that's what we had. Yeah, that is what we had. Always got to write down the question correctly. Alright, and now we want to convert this to r cis theta. Our first step was finding r. So we know that r was equal to what? Square root, first value, square it. Plus, second value, square it. Easy. That's all you need to know. Well, actually, it'd be good to know that it's actually the radius, but that's all you need to know when you're just doing questions like this. And then you'll get 3 over 4. Alrighty, looks like we've got a nice value here. That'll give us 4 over 4 is equal to 1. So our radius is equal to 1. Bang, already one value down. And our next step is finding theta. So we'll use the same principle. Cos theta on our real and imaginary axis. Look, our real value is positive and our imaginary value is negative. Easy. Somewhere down here. We already know that. So we already know it's in the fourth quadrant. That's just the first thing you want to pick out. We know it's in the fourth quadrant, and we know our radius is 1. So that helps us out already. We want to go this value here, which is 1/2. I'm not even going to write. Actually, yeah, I'm not even going to write it anymore. What am I doing? I will write it. It's got a bit messy. We know this value here is 1/2. We know this is 1. And we know this is negative square root 3 over 2. The lengths here. Sounds like thunder. That's no good. Alright, cos theta is equal to adjacent over hypotenuse. So therefore, we've got 1/2 divided by 1 because our radius is 1. So we know cos theta is equal to 1/2. Sin theta is equal to our opposite over hypotenuse, which we got, what, negative square root 3 over 2. Negative square root 3 divided by 2 over 1, which is just equal to that. And then we know it's in the fourth quadrant. So instead of doing our tan value, we can actually I'm pretty sure we can actually just take a shortcut. We know it's in the fourth quadrant, so therefore we're going to just evaluate this one here, or even the sine value, I don't even know what I'm saying, for it to be in the fourth quadrant because we know it's in the fourth quadrant. So we'll just chuck the cos inverse and go theta. Theta is going to be equal to cos inverse 1 over 2. That'll give us our value of, well, we know cos inverse 1 over 2 think that is pi 6. So we got our theta is pi 6. Pretty sure that's right. Hold on. Yep, that is right. No, I don't know what I was thinking there. Thankfully, I managed to salvage that. Pi 3. But we know it falls in the fourth quadrant, so therefore negative. Yeah, because it goes downwards. Yep. Goes in the negative direction. I'm pretty sure that's it. I'm just going to quickly double check that with tan value. So we've got our tan theta, which will just be equal to negative square root 3 over 2 divided by 1 over 2, so that'll just give us negative square root 3. So therefore, from this, we know that it's going to be in the second or the fourth quadrant, but we know it's in the fourth quadrant. Therefore, our theta will be equal to, yes, we'll get 8 pi on 3, and it'll be in the negative direction. It'll just be in this fourth quadrant here. So therefore, after knowing that, we can kind of prove ourselves there. You get, then again, I do really hope these are all right. I rarely rewatch the video to check if I got it right. Little care, doesn't matter. In polar form, we get our radius is 1, so it'll just be 1 here. I'm not going to write 1, and then it'll be cis negative pi on 3. See, thankfully, that falls within our range, so we're valid. And that's that. And now I'll quickly just go over one more thing, because you can also be asked, this one's complex numbers to polar form. So you got your rectangular component into polar form, but you can also be asked to get polar form back into its rectangular components. So I'm just going to use this example here, which will be, I don't think you can actually see me move my mouse or not 100% sure. It's going to be this one here, square root 2 cis minus 3 pi, cis, and then negative 3 pi over 4. So as I showed you here, that's also equal to this expanded version here. So I'm actually just going to see if I can do it up here. So therefore we know that square root 2, and then you get cos, square root 2 cos negative 3 pi on 4, plus I sine negative 3 pi on 4. And then this, we want to simplify what's inside our brackets first. So cos negative 3 pi on 4, cos values are negative, is just going to give us negative square root 2 on 2. And then plus I sine, that'll also give us negative square root 2 on 2. So then that'll turn this plus into the minus square root 2 on 2. I actually do have a video on how to get your exact values quickly like that. I just use the mental version of that. So we can expand this here, it'll just be negative 2 over 2 minus I 2 on 2, which is just equal to negative 1 minus I, which is our rectangular component that we got. So just if you're ever asked to turn this, your polar form, into complex numbers, just remember the expansion and just keep going. Just keep expanding and simplifying. That's pretty much it. It's easier to go back than it is to go forward, but going forward, I could do it for days. It's pretty fun to do. That's pretty much it. Just always remember your argument, argz, you want your theta to be greater than negative pi or less than or equal to pi, so within this range here. You want to be within that range there, as well as just how to find r and then how to find theta. That's pretty much what you want to know, and then that's all you need to know. You can graph, obviously, the square root 2 cis negative 3 pi 4. You can graph it that way, but it actually gives you the same coordinate as the rectangular components. Exactly the same coordinate, just a different way you can graph it. Alright, we'll call it a day.